Alright, this is 4th grade material, what they're learning in the first unit. So you have an idea of what's going on in the classroom. So we have this huge number here. And they have to be able to say it for one, which a lot of students have a tough time doing. So it would be nice to just make some big numbers before they go to bed. And maybe like 3 a night or something, and they have to say it to you. See if they're actually saying the number right. Help them out. So they need to be able to say it, they need to be able to write it in word form, write it in standard form, and write it in expanded form. If you're like, I maybe know one of those. Well, that's good. So we're going to start with word form. Word form is going to take forever because this number, yeah, it's pretty big and there's lots of digits to it. So they're going to actually write it totally out. I have, in this number, separated by commas, 3 sections, and those are called periods in math. And I have my millions period. So what's in the millions period? 15. So I have 15. And what period am I in? The millions. So it's going to be 15 million. And I have comma. Now I'm at the next period. This number here is 326. So I'm going to write out 326. And what period is it in? This represents the thousands. So I'm going to say 1,000 period. And then I have my final period, which is 500. 500. And that's the ones period, and I don't need to write that. So here it is, 15,326,500. Word form takes a while. Standard form. Standard form is the one that most kids like. It is just the number. I'm just writing out the number. That's standard form, straight up the number. And then expanded. That is taking the number and expanding it out all the way depending on what each part is worth. So I'd say, all right, I have 1, 2, 3, 4, 5, 6, 7, 8 digits in this number, all with a different place of value. And so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to write in the digits. What digits do I have? I have 1, 5, 3, 2, 6, 5, 0, 0. And now I need to fill it in with what they're actually worth. Because if I add 1 plus 5 plus 3 plus 2 plus 6 plus 5 plus 0 plus 0, guess what? I'm not going to get back to this number. So I have to be able to get back to that number and show how much each one of these numbers is worth. So 1 is not worth 1 up here. It's worth, what place is it in? It is in the 10 billions place. So if I take all the digits that are after it and replace them with zeros, that's the 10 millions. So that has 3, 6, 7 zeros in it. And now I go to the 5. That's not worth 5. That's worth 5 million. And guess what? That has 1 less 0 than the 1 did. So I have 6, 7. Now I have 6 zeros. Now what do you think I'm going to have? It does go in a pattern. This is the 100,000s place. So I have 3 of those. So it is 3, not a comma. It is 300,000, which has 5 zeros. The 2 is going to have, so we had 7 zeros, 6 zeros, 5 zeros. Now we're at, should have 4. Do you agree with me that it would be 4? Because this is in the 10,000s place. So it would be 4 zeros, 20,000. Then we're in the thousands place, so we're at 3 zeros. And now we're in the hundreds place, 2 zeros. And these are just zeros, so I don't need to even have them on there. Okay? There we have it, expanded form. It's huge. And if I add these all up, I'm going to get that number, the original, the standard form. All right, then they went on, and after working through being able to say numbers, like read them, write them in standard form, in word form, and in expanded form, they went on and found the value. So we just take a number and pick a digit and figure out what is that number worth. So I have underlined the 2 in each one of these numbers. The thing is, the 2 here is worth a different amount than the 2 here, which is worth a different amount than the 2 there. In this case, the 2 is worth 2 thousands, because it's in the thousand spot. So if I have 2 thousands, 1,000 and 1,000, that would be 2,000. This is worth 2,000. This 2, I have 2 ones there. So if I have a 1 and a 1, that's 2. This is just worth 2. If I go to this 2, it's not ones, it's not thousands. That 2 is worth 2 10,000s. So if I have 10,000 and 10,000 together, that would be worth 20,000. Okay? Alright, moving on. Then they went on to rounding. So now I have a number, big one, and I need to round it. And it depends on, what I tell you to round it to. So in this case, 166,742. And I'd say, well, I want you to round it to the thousands. So first off, what they learned to do is to go ahead and look at where is my thousands. It's right here. That's where I need to round to. So I need to decide, is that going to stay the same? Or am I going to move it up in the world? So in order to determine that, we have to check the number that's sitting to the right of it, the 7. So since that is 5 or more, 7, I'm going to take this number and I'm going to bump it up. Bump it up. So it's going to become 167,000. So I've taken it and I've rounded it to the thousands spot. I just check this number. There's 5 or more. Boom, it goes up. This number. All right, let's look here. We're going to round to the 100,000s. Meaning, I'm going to highlight where the 100,000s is at. In this case, it's here. And I'm going to jump over and look at what's sitting next to it. It's a 3. Is that 5 or more? No, it's not. So the 1 is going to stay. I'm not going to move it up. It's just going to stay there. And I'm going to be at 100,000 because I was rounding it to the 100,000s. And if you think about it, is 132,505 closer to 100,000 or is it closer to 200,000? It's closer to 100,000. All right, stepping it up. Now, from rounding, let's step it up to what we call inequalities. And when I say inequalities, those are these. I have certain symbols, which you could say that one is the equal sign. And in this case, are those equal? No. You can tell instantly they're not equal. They're not exactly the same. This sign here, it looks like an L that's squished down. That is the less than sign, which means the other one is the greater than sign. So we're trying to replace this blank space with one of these symbols. And we already know they're not equal. So we need to determine, is 45,423 less than this number? Or is it greater than this number? And we have to be able to say why. So let's start. What most students will like to do is line these numbers up vertically. And I need the place values to match up. So let's say I do that over here off to the side, 45,423. The number in the ones here is a 7, so I'm going to write it under the 3. Then the tens is a 9, 8, comma, 4, 4. Okay, so they all, each digit matches up with something else. Now I'm going to start from the greatest place value and work right. So I am looking at those 4s. They're the same, so I can't do anything there. So I have to move on. So now I'm going to highlight something else. Let's try, I guess I don't have many colors that will show up for you. But let's say I look at the next place value, the thousands. And now they're not the same. So now I can determine 5 is bigger than 4. So this number here is going to be greater than 44,897. And the reason why is because 5 thousands is greater than 4 thousands. That's the place value we were looking at. Alright, let's try another one. So I have 2 numbers up there. Now they're a little bigger. Now we're going into the millions. Trying to determine less than, greater than, or equal to. Can we say equal? I'm looking at them and oh my gosh, they are so close to each other. But no, they're not equal. Oh yeah. So now I'm going to go through, either line them up vertically, or here for me I can see they both have 9 digits. So I'm just going to start at first digit, 7, 7, same. I have to keep going. 3, 3, they're the same. 5, 5, same. 2, 2, same. 9, 9, my gosh. 1, 1, 0, 0, 0, 0. Oh, finally. The final digit, 0 and 1, both in the ones place, are different. This is smaller than 1, so I'm going to say this number is less than that because 0 is less than 1. 0 ones is less than 1 1. Okay? Okay, moving on. I'm whipping through these things, but I'm just kind of giving you a glimpse of what's happening. They also worked on ordering numbers from least to greatest, or greatest to least, or being able to spot the greatest number or spot the smallest number. Okay? So let's go ahead and start by trying to list them from least, which means the smallest, to the greatest. Alright, the least number. Well, they all have the same amount of digits. So you know what? I'm going to go ahead and look at that first place value, which is the 10,000s. And one of them is different right here. So this one compared to those 2 2s is smaller, which means I already found my least, 14,762. Then, next step, this one is less than, what's my next number? So this one's out. They both had 2s, so now I'm going to go to the next number. That's a 2 and a 1. That place value is the thousands, and the 2 is bigger than the 1, meaning that this one is bigger than this. So 21,046 will go next. And taking up the greatest position will be, this one is smaller, less than 22,981. Cha-ching! Okay, now we get into kind of the final concept, which was money. We all like money. So let's say we have $4, 7 dimes, and 2 pennies. Typically this might be drawn out for them, the actual dollar bills and the dimes and the pennies, but I just wrote it up. They'll want you to write this amount with a dollar sign and a decimal point. Could you do it? So I have a certain amount of dollars, a decimal point, and a certain number of cents. So I'm seeing I have $4. My dimes, each one of those is worth 10 cents. So in this case, I know I have a total amount of 70 cents. Over here, 2 pennies. 1 penny is worth 0.01, or 1 cent. So 2 pennies would be 2 cents. So 70 plus that 2 is going to be 72 hundredths, or 72 out of 100, 72 out of $1. So